S-lactic acid is produced by humans and other mammals during normal metabolism and exercise. A sample of S-lactic acid was found to have an enantiomeric excess of 74%. Okay, then it's asking us how much of the R isomer is present in the sample. So at first glance, you might think, well, they're just talking about S. Why are we being asked about R? And so we got to come back to this term enantiomeric excess. So unless you have an enantiomeric excess of 100%, you have some of the enantiomer. So enantiomeric excess. We need to know what this means, right? So this is going to be the portion of your solution essentially that's going to cause that solution to rotate plane polarized light. So it's only going to be the amount of the isomer that you have that's not being canceled by its enantiomer. Okay, so excess means how much more do you have that's not part of a racemic mixture. Okay, so that excess means in excess of the racemic. Okay, so it probably still sounds complicated, but the math here is actually pretty easy. So it needs to add up to 100%. So 100 minus 74% would tell you how much of this you have present as a racemic mixture. So it means you have 20% that is racemic. Okay, so from that enantiomeric excess of 74, that means you have 74% pure S. But then if you have 26% that's racemic, racemic means a 50-50 mixture. So you need to divide that by 2. So in that racemic portion of the solution, you have 13% R and 13% S. Okay, so that means that overall in this solution, you have 13% R, and the percent S, you're going to count this 13 that's racemic, and then the part that's in excess of that as well. So you would add those two together to say that it's 87% S. That's what the solution would be. Okay, so I know it sounds confusing, but the reason why we measure enantiomeric excess is because this is going to affect how it rotates light. So that 13% R cancels 13% of the S. And so it's the remaining 74%, that enantiomeric excess, that causes the plane polarized light to rotate. And that's what you can measure in a polarimeter. Okay, so a whole lot of extra information I just gave you there. Let's go back to the questions he was asking us. It's asking us how much the R isomer is present. Okay, so you got to make sure we answer about the right one. It's asking us about R. We've determined that the R is 13%. So we want to make sure we select accordingly. And this 87%, we already said, that's the percentage of S.